Hello everyone and welcome back to Atman Unlimited. It's here, finally. We're going to put these probes in the machine. First, let's go to the machine and we're going to work on the tool setter, and then let's talk about where I'm going to place it and why I prefer to place it there. And then I'll also discuss what I came up with the cable routing, which I think will give me the easiest install and the best operation. So first, we'll go to the machine and take a look where we're going to install it. Well, we're in the machine here, and not too comfortably at that, but hey, we'll take a look. So we've got four main places that we could put this probe. We could put it here, we could put it here, we could put it over here, or we could put it over here. Now, the wiring for the probe, the best way to do this is to put it over here on this side somewhere, because the wire wants to go this way and then follow the seal tight for the X motor drive. Because above my head is approximately where the main wire trough that runs between the control box and the pendant is. So logically, it wants to go over here. But if we put it over here, let's think about what's going to happen. So you're machining a part. You want to do tool break detection, which means you're going to do a tool length probe on the tool between operations to see if it broke or not. If you put the probe on this side of the table needs to traverse all the way this way so that the spindle's under the probe. Now what that's going to do is, if you have a tall part on the table, it's going to push that tall part under the tool changer. Now, between the tool change height and the base of the table on this machine is 20 inches. So if you have a tool that's 10 inches long and you have a part that's 10 inches tall, theoretically, they could collide if the part ends up under the tool changer. Now, above tool change height, you have an extra 4 inches. So it is feasible to machine a part that's 10 inches tall with a tool that's 10 inches long, because after the tool change, you can raise the Z head up, take advantage of the extra 4 inches above tool change height, and machine the part. And you can safely make a tool change if you push the table all the way forward and then all the way this way, because now your tall part won't be under the tool changer. So with that circumstance of wanting to push the table all the way forward, that means I want the probe on the back, and then by wanting to push the table all the way this way, it would be X positive, I want to put the probe over here. So that way, I can move my part out from underneath my tool changer when I go to change tools and do tool probing. Now, the bad part about putting the tool setter over here is that, primarily speaking, on the Fidels, the coolant nozzles are on this side of the machine, pointing that way. So the majority of my chips end up going this way. So as a negative side effect of putting the tool setter here, it's going to see a lot more coolant spray and it's going to see a lot more chips. So that's one of the downsides of putting it over here. Now the other downside about putting it over here is remember we talked about the cable routing, it wants to go over here. Now I've seen a couple of installs where they'll put the tool probe over here for the reasons we talked about, but then they'll run the cable that way. Now I do not like that at all, and I am not going to do that, because now you put the cable under the tool changer. And if you have long tools, then the cabling could get snagged on the tool changer. Bad situation. So we're going to put the tool setter here, and then what we're going to do is we're going to run the cable this way and then loop it back around, and then we're going to come underneath the edge of the table over to here and then come out and then come up to the wire trough that's above me. Okay, this is how we're going to do it. The wire off of the TS27 tool setter is a 2-conductor cable. It's like an SO cable, and it's sealed onto the back of the tool center. Theoretically speaking, you don't have to put it in anything. However, it's good practice to put it in something. Now ideally, you want to put it in 1/4 inch diameter seal tight. Well, the only place I could find 1/4 inch diameter seal tight, they had a minimum order of like 100 feet or 200 feet, and I'm just not going to shell out that much money for seal tight that's going to be laying on the floor. So I found the next best thing, which is polyurethane tubing. So this is resistant to the coolants that I use, so it shouldn't break down with the coolant, and it's also very abrasion resistant. So rubbing it on the parts of the machine while the axis is moving shouldn't be a problem either. And if it does wear out, it's really easy and cheap to change. So I really don't care if it wears out after a couple of years. I'll just change it. Then I got a piece of standard EMT. Now, normally you don't use EMT in here, but this was the best way that I could figure out how to do this easily. So I'm going to put this inside this to run it back here. So let me show you why I need to use this and put this in this to run it back there. I'll show you some of the complications of doing this and some of the things that you need to think about when you're doing any of these additions to a machine like this. So let's go handheld, and I'll take you in close and show you some of the obstacles we have to avoid. So that looks like there's just absolutely a ton of room back there, right? Well, let's jog Y all the way back. So this is Y all the way negative. And then let's jog Z all the way down. So this will be Z all the way negative. And now we'll jog X all the way negative. Okay, let's walk around to the side of the machine. So all the room that you thought you had just went away. And to show you how little room you really do have, that's about the width of my finger. So there's barely a 1/2 inch in between the Z cover and the back of the table. So if you were to run that conduit along the back edge of the table, you might have some collision issues on the way covers. Now, if we look under, we've got this nice gap here under the edge lip of the table, right? Now, where the conduit comes into play is the table stops here. And then this is way cover, and underneath this way cover is the lip that supports the way cover extension. So you cannot drill any holes on the bottom lip of this way cover, or else it will interfere with the support of the movable cover. So that's where the conduit comes in. I'm going to mount the conduit to the bottom of this, I guess you could call it a way cover, and then I'm going to let the conduit extend out between these two marks. So this is the mark for the edge of where Z ends, and this mark is where Y ends. Now, when I'm all the way in this position, what I'd like the tubing to route is I'd like to have it come out and down a little bit, and before it starts to loop up, so that it doesn't kink. So I'm going to bend the conduit so that it exits right around here, and I'm going to bend it down and then to the rear a little bit. So that will guide the tubing down and out so that it'll start looping up then. So that's the game plan of where the conduit is going to come in. And then we'll remove this rear guard and then drill it and then put 2 hangers underneath it to hold the conduit up. We're going to start the install by figuring out where and how much to bend the conduit. So on the one side we want the conduit to push out and down a little bit, and then on the opposite side we just want it to push out. So once we get the initial bend done, we'll measure it for size, And we'll take it back over on the bandsaw, lop it off, and we'll have our piece of conduit sized. Little deburr. So now I have to adjust how much down angle I want and then mark the conduit so then I can put the other side bend in at the right axial rotation so that the bend on the left will be parallel with the bottom of the table, and then the bend on the right will have that downward trend. Now we're going to remove the rear way cover, and then that will facilitate us being able to mount the conduit to it. A little cleanup is needed. So we got our rear way cover removed. This is the bottom edge facing you. So this is the face that we want to mount this piece of conduit to. So now you kind of get an idea of what we're trying to do. I actually have it rotated backwards. So this piece of conduit will just sit neatly right up underneath the edge of the table, out of the way, so it won't hit the rear covers. And then it provides rigidity here. I'm just going to do 2. I might put in 3 clamps just so that it doesn't vibrate at all. And then it gives us a little extension out the ends to suspend that flexible tubing a little bit farther so that it doesn't get in the way of the Y or Z covers. So that's why I wanted to use this small piece of conduit. Now what I'm going to do is I'm going to use these small 1/4 20 socket head cap screws, and I'm going to put the socket head on the inside, because what you have to keep in mind is that your trucks run right along this inside edge here on this cover. So anything towards this lip, you could hit your truck. So we're going to put the screw as close to the vertical face as we can, and by using the socket head cap screw, it will keep an extremely low profile. So let's punch some holes in it, get this conduit mounted. We have our piece of conduit mounted onto our way cover, and on the back side we have our socket head cap screws, so we have very little lift above this, so our bearing trucks for our linear arrays won't even come close to colliding with this. And conduit's nice secure, so I'll provide a good guide for our tubing. So let's get this mounted up back on the back of the table, and then we'll run the piece of polyurethane tubing through it, and then just test it out and see how the routing works. Now that we have the conduit mounted to the way cover, we are going to reinstall the way cover. One thing that I did not show in the video is after I reinstalled the way cover, I did put a plastic grommet on the end of each end of the conduit to prevent the plastic tubing from chafing on the end of the conduit in case it slid a little bit. So now we're going to fish the plastic tubing through the conduit, and then we're going to work on getting it attached to the upper part of the machine. So here we're removing the wire way from the top of the machine. Now this wire way runs from the control cabinet to the pendant. I just piloted a twist drill hole real quick, and then I used a unibit to open up the hole. Unibits are nice just because they tend not to grab and they don't break your wrists while you're using a hand drill. And now we'll connect the tubing to the fitting. We've got our conduit run. We know where we want our tool setter to be generally. But let's talk a little bit more in detail of where we want this tool setter to be exactly. Now, if you're using the Renishaw macros and software, you only need access to 3 sides of the probe if you're going to be doing diametrical offsets. If your software requires using 4 sides of the probe, you're going to be chewing up a lot more real estate. Because the dirty little fact with tool setters is they have to be somewhere in the work envelope. And where that somewhere is, chews up your real estate. But if I only need access to 3 sides of the tool setter, if I have a larger diameter tool, so this is a 1.5" end mill, I believe. A viewer sent me a whole bunch of really large cutters, so I appreciate it. Thank you for sending these. So we'll use one of these as an example. Even if I set this tool setter probe at the very edge of my work envelope, which is approximately right there, the center of the tool can still line up with the center of the probe when it's behind it, in front of it, or here. So I have access to 3 sides of the probe, plus I can offset my diameter to touch off the length here, here, and here. Now by doing this, even if I take into account the largest tool this machine can really use, which is about a 3-inch tool, I can touch off the back side and the front side, and I'm only losing approximately 1.5 inches of my work envelope, because the tool is going to hang over 1.5 inches. So I can have a part run all the way to the back of the table within 1.5 inches of where the tool setter is, and still machine it and not have to worry about my 3-inch, mill contacting my work while it's touching the tool setter. Now, if you need access to all 4 sides and you want to do a 3-inch tool, now you have to have this guy in your work envelope a lot. And it can chew up a lot of work envelope very quickly if you're using larger tools. So by only using 3 sides, we can keep it over here and everything will be good. So when we mount this, the way that we mount this is there's 3 screws on the bottom of this, and there's 2 bases. We take out these 3 screws, this lower piece will come off, and then we use a standard T-nut to attach this lower piece to the table. Then we put these 2 screws back in and snug them up, and then just kind of hand tighten this screw, because this screw comes into an adjustment later. So then once we get it mounted on the table, we'll finish running the conduit to the probe and get it wired, and then we'll have to align the stylus. So let's get that done. We're going to start by cleaning and stoning the table. We just want to remove any burrs that might be on the table so that the base of the probe sits nice and flush. Then we'll use a standard T-nut and a bolt to hold the base of the probe down, and then we can reattach the probe to the lower base using the cap screws. Once this is done, we'll take the wire and feed it through the tubing and get it up to the top of the machine. And then I needed to remove one more wire away to get the wire all the way into the machine cabinet. I left a loop of wire up on top just in case, and then we connected the conduit. We completed the physical installation of the TS27 tool setter. So we've got it mounted at a table, conduit run, wires fished through the conduit, and it's fished all the way back to the control cabinet. So it's all ready to be wired. Now let's do the physical installation of the OMM. So I've got the spindle probe in the machine, and then we're going to temporarily clamp the OMM up where I want to mount it, and then we'll power it with a 10-volt supply, and then check the green signal indicator and move the spindle up and down and make sure that I have a good signal throughout the full travel of Z before I drill the holes and mount it. So let's get started. I wanted to mount the OMM at the top of the machine originally, but after some testing, I couldn't get a good signal through the whole travel of the spindle. So I ended up moving it to the side of the machine. And it's at a funky angle so that I could point it at the spindle at the right angle. So it worked out in the end, just not as clean as I wanted it to be. But it's still above where I generally cut, so it shouldn't get covered in chips. So then once we got the OMM mounted, same procedure as we did with the tool setter. Drilled another hole in the top of the machine, put another fitting in the top, and then we'll route the wire up through the fitting and then attach a small piece of conduit between the same tubing between the OMM and the top of the cabinet. Then we'll run this wire back to the machine cabinet, and we're going to bundle everything up, throw a couple of zip ties on it, and that way when we reinstall the cover on this, we don't have to worry about crushing any wires. Now I'm reinstalling the back cover. That one you got to be really careful with because it's easy to crush wires when you tighten that one down. And then the upper cover I put on the front of the machine first and then pull it down, and then you can look down the length of it and make sure that you're not pinching any wires while you seat it down. Then we can put the nuts and bolts on it. Okay, that's going to complete the installs for the tool setter and the OMM. We've got everything routed back to the machine cabinet, the control cabinet, and everything's all buttoned up. All the conduits are tightened up, so we are ready to go. Next video, we'll wire it all up and give it a test and see if it all works. Thanks for watching. We'll see you on the next video.